Okay, so let's get started. Transitioning to Azure networking. The devil's in the firewalls. I'll start out um, with a little bit about myself. I'm Kobe Abrams, a cloud security researcher at Varonis. I have experience in various cybersecurity fields. Mainly now I'm focusing on IaaS security in Azure, and I previously led some cybersecurity courses. So that's just a little bit about me. The first question that I want to talk about is why. Like, why are we here? Why are we talking? So we have on-prem networking and Azure networking, and the two are very similar, but can also be very different. And I'd like to talk a little bit about the differences and some security issues that we might have with them. So on-prem, we have routing and switching. In Azure networking, it's really interesting. Layer 2 is basically abstracted. So you can't really have any layer 2 communication between endpoints, at least not directly. To your endpoint, it looks the same. The interface is the same, but at the lower level, when you look a little bit deeper in to what's going on, you'll see that layer 2 is handled by Azure completely in a different manner than on-prem networks. So with on-prem networks, we have a lot of physical constraints, and this is really something that Azure networking takes care of for you. There are no physical constraints. You don't need to have a 50-meter cable stretched between two different offices. You just, um, with a click of a couple of buttons can deploy large networks, small networks. So really, that's something that Azure networking um, creates that's very comfortable. With on-prem, you have segmentation through network appliances. If you want to create some kind of um, network rules or segmentation between different areas of your network, you kind of have to use different physical appliances or physical connections to kind of create that. Um, with Azure, it's not exactly through appliances. There are various different controls. There are many different controls in Azure and also third parties that you can use to create segmentation and create different network architectures. With on-prem, you have a very flexible design, right? You can pretty much do whatever you want. If you want to connect cables in weird ways, you can, and strange things will happen. With Azure, you have a default behavior where Azure networks behave like flat networks. Endpoints can communicate between each other. And there's a default behavior. So if you just create a virtual network, um, you have that kind of default behavior, and most things are steering you towards a hub and spoke uh, kind of architecture. With on-prem, what you see is what you get. So if I look at my switch in the IT closet, you kind of have what cables are connected where, and pretty much what you see is what you get. You have control over the switches, you have control over the appliances. You're pretty much completely in control, which can introduce its own issues. With Azure networking, there's more than that. So we're going to look a little bit at that. So what are we going to talk about today? We're going to talk a little bit about some of the basic Azure network building blocks, kind of just to get to know them. Uh, Later on, we're going to look at some security concerns that may arise from using those building blocks and kind of misconfigurations that may be created. And we're also going to look a little bit at how to remediate those and kind of figure out how to better address your needs when pivoting to cloud networking or when using cloud networking. After that, we're just going to look at a short summary of what we talked about, some conclusions, what we could do better in the future. And in this part of the Azure Network building blocks, we're going to look at VNets and subnets, network security groups, resource firewalls, private and service endpoints. So let's jump in. I'm going to start with just a very simple internal network, right? This would be maybe much smaller than anything that anybody would deploy today. But it's the basic idea that I want to get through is that, you have um, your PC is connected to a switch, it's connected to a router, to a firewall. You've got a VPN over here, um, and and really you can configure these um, in many different ways. So you could have all of the traffic going through the firewall. You could have only some of the traffic going through the firewall. You could have internet access completely blocked off, internal access blocked off. Um, if you wanted to create access to a third party, you could use the VPN to create access to either the database or a file server. And really you can control kind of uh, what's going on with these network appliances that we have here and kind of use them to create the architecture or the use cases that we want. So what we're going to do is we're going to look at the Azure counterparts and kind of figure out how we would create a sort of similar network with those. And we're going to build it together. So we have VNets and subnets. What is a VNet? A VNet is basically an IP address space that's completely disconnected from any other VNets you have. So you can have multiple VNets in either a subscription or in an account. And they can be connected to each other, right? You can connect two VNets, or you can connect them to your on-prem network through various different controls that Azure allow. Subnets live within each VNet, and they kind of split up that IP space, which may be very large, into smaller subnets. And these two controls or these two resources basically replace switches and routers. So I don't have to deal with switches and routers when I'm deploying an Azure network. I don't have to think about them. I can just create a VNet or as many VNets as I would like, and I can create subnets within those VNets. So like I said, layer 2 is kind of abstracted in the Azure network. So it's really comfortable just to be able to create these resources. One thing that's interesting to point out is that inside of a VNet, by default, even if you've created multiple subnets, communication is enabled between all endpoints. We're going to talk a little bit more about that in the future, and just something to keep in mind. The next resource I want to talk about is network security groups. So we talked about how we have VNets and subnets, but really all endpoints can communicate between themselves, which is probably not something that we want to go on. So network security groups are the most basic control to kind of remediate that issue. You also have Azure firewalls. The difference is that Azure firewalls are more like the firewall appliance that you would have in an on-prem network, whereas NSGs are applied to resources. You can apply them directly to a resource or to a VNet. NSGs can't be used as a gateway. An Azure firewall you can put in your network and use it as a gateway with a public IP to the internet. NSGs don't do that. So, like I said, they can be applied to specific endpoints or to an entire subnet. So I could limit the access between subnets, and it's basically like a firewall or more like access rules that you would have in your on-prem network. So coming back to just the basic network that we're building, we have the virtual net. As you can see, the VNet with a couple of subnets in it. And we might have in one of those subnets some resources, we might not. And you can also see the NSG protecting either a subnet or a specific resource. And something interesting is that those two NSGs could be the same NSG. They could have the same rule set applied to them. So you could decide that an entire subnet needs port 445 blocked, And also this resource in a different subnet should also have that applied. You could do that. So that's really interesting. Now, continuing with the various kinds of firewalls that we have, right? We had Azure Firewall, we had the NSGs. We also have something called resource firewalls. And so far, I've been talking about resources that live within your subnets or your VNets. And resource firewalls protect resources that are hosted by Azure, such as Azure SQL Server or storage accounts. So um, if you have a storage account with a public IP or public endpoint, it's hosted by Azure and it doesn't really live within one of your subnets. And the Azure Resource Firewall basically limits access to public-facing IPs. So you can say that you can create a whitelist of IPs that can connect to that storage account. The name firewall is a little confusing, in my opinion. It's more like an IP-based access list. You don't have control over the ports because these services are hosted by Azure. So it's more like a whitelist. It's more like an IP-based whitelist. So this is what it would look like. You have the internet, right? Anybody on the internet who can connect, and basically they have to go through the resource firewall in order to connect to your SQL server or your storage account. Now, like we said, that we have these storage accounts or SQL servers that are can be hosted with a public endpoint, and they're hosted by Azure. So if we want to connect these resources to our subnets, to the VNets, so that we can have access through them, there are a couple of ways of doing that. So private endpoints and service endpoints are both solutions to this problem. They're pretty similar, but there are some differences. So with private endpoints, we get a network interface within the subnet that actually brings us straight to an Azure hosted resource. I'm going to use storage accounts as an example. So if I have a storage account called My Data, and I would like to be able to access it with an internal IP so that my virtual machine that I'm accessing from doesn't need to go over the internet, I can do that with a private endpoint. Service endpoints, on the other hand, don't give you a specific network interface. They just route traffic, all of the traffic to storage accounts. They change the routing so that it goes internally within Azure's network and brings you to whatever storage account you would look for. These resources I find are most like a VPN. You can also create private endpoints that can connect your resource to a different VNet. So it's kind of like a VPN that allows you to share over a secure tunnel, right? So this is what a network that has all of the things that we talked about kind of implemented in it, and I think it's in a way similar to the on-prem network that we were also looking at before. So here you have the storage account that has a private endpoint straight into the subnet that's protected by an NSG, and we also have the resource firewall that's again, resource firewalls only protect against only protect or only allow you to filter by public IPs. So the network, the private endpoint is not really bypassing, but it's not going through that resource firewall. The service endpoint we can also see is connected to one of the subnets. So those are the basic building blocks that we need to know going into the next step. Of course, there are many more resources and many more controls that you can use to create your subnets, and these are just a few of them that I found interesting. So we'll move on now to some possible security concerns and misconfigurations. We're going to talk about NSGs and how they work with private endpoints. So, right, NSGs where our access control and private endpoints are the way we're getting access to Azure hosted services. We're also going to talk about NFS and storage accounts. There's some interesting nuances there. Also going to talk about object replication in storage accounts, public network access through some certain settings, and hidden SQL firewall rules. And finally, we're going to talk about an attack scenario and kind of see what it would look like. So starting off with Azure storage accounts, NSGs with private endpoints. By default, NSGs do not apply to private endpoints, right? We said private endpoints get a network interface within your subnet. By default, any NSG on that network interface, whether it be on the subnet or whether it be on the interface itself, does not apply. The rules do not enforce traffic control to that interface. And this is it was an odd setting that I came along. You can turn on a setting for that subnet that says that network security groups should apply to private endpoints, but by default, they do not. So creating private endpoints through some flows also resets the setting. So even if I decided that I want my subnet to enforce NSGs on private endpoints, it turns out that when I create, for example, a storage account with a private endpoint through the portal, that setting will be reset for that subnet. So we can see, right, if you have network security groups enabled for the subnet above, it will be disabled for private endpoints on the subnet only. Other resources on the subnet will still have NSG enforcement. So other resources being other resources, and again, private endpoints will have that option disabled for them. So this is something really interesting because there are some obscure settings. They may not make 100% sense to you, but because we have so much going on behind the scenes, then things tend to be, not always what we expect. So it's something really important to notice, especially if you're relying on network segregation for securing your network as you should. So also these settings can be changed, right? Things are dynamic in these settings, and it's important to kind of monitor them. So really just making sure that you're aware of what's going on and what the documentation says, and monitoring your settings. So this issue is kind of related to the next issue that I'm going to talk about, and we'll see why in a moment. So we have NFS in storage accounts. NFS is a file sharing protocol mainly used in Linux systems. And storage accounts support using NFS. You can, when you create a storage account with NFS enabled. But it misses one important feature. And of course, it's stated in the documentation plainly. But I think it's pretty problematic and something that you should really know while you're using NFS in storage accounts. NFS in storage accounts don't really support any form of authentication. So once you've created a storage account with NFS enabled, any endpoint for that storage account that you can access NFS with creates access to anybody, or an anonymous access to that data. Even if I've set Entra and role-based access to those objects, if I've added ACLs, there is no authentication method, so anybody can access that data with NFS. Really, this means that the only thing protecting your data are the network access controls that control the access to that storage account. NFS is only available on private endpoints and service endpoints. It's not available on the public endpoint for storage accounts. But I find it really interesting that the only thing that's protecting your data here are the network access controls to private endpoints. And we saw before that network access controls for private endpoints can tend to be a little strange, right? If I don't have that setting enabled on my subnets that we talked about earlier, that enforces NSGs on private endpoints, I might be creating a much wider access circle than I originally intended to. And what I think is important to kind of take away from this is that NFS is a protocol that you might be using in an on-prem network, but it may be a good idea to kind of look at what you can change and update, right? What you can move forward with when you're moving to cloud storage or cloud networking. How can I fit my workload to the cloud and not have the cloud fit my workload? Because legacy is important, but it can also introduce some problems. So another feature I'd like to talk about in storage accounts that has to do with a little bit with networking is object replication. So object replication is a really useful feature. It copies objects between storage accounts so that you can either create a backup or automatically share certain things that you'd like to share. Really a pretty useful feature. It doesn't require any network access. So what I find really interesting about this is that you've basically created, either a resource firewall rule, or you've properly configured your private endpoint so that NSGs apply. But there are still settings that you can create, like object replication, that can access your data behind the scenes. And this is something that's very unique to the cloud, right? Usually when I'm in an on-prem network, I kind of look at like what I have and what my settings are. And if I can't access a machine network-wise, then really I can't do much with it, right? Everybody needs network access. Everybody needs to configure firewall rules. And in the cloud, because Microsoft and Azure have native access sort of to that resource, they can access or certain features can access that data. So again, this feature bypasses any resource firewall rules I've created. And also, one more thing that I thought was a little problematic, doesn't write any access logs. So even if you're looking at access logs and kind of monitoring that, this feature won't really write those. So it's important to kind of monitor around them as well. Okay, one last thing that we have allowing access to Azure. So what do I mean by that? In a lot of network controls, like resource firewalls, you have the ability to allow Azure services access to that resource. Some Azure services do use network access to facilitate whatever feature they're giving you. And when that's true, you need to be able to give access easily. So the way Azure decided to do that is usually a little checkbox, and we have two such checkboxes here. We have allow Azure services on the trusted services list to access the storage account, which pretty much does what it sounds like. It exists for storage accounts, and it only allows access from Azure managed services. So what I mean by Azure managed services are services where Azure is creating the request, right? It's coming from Azure. It's coming from a trusted third party in this case. The second one is allow Azure services and resources to access the server, which to me sounds very similar. Sorry. And what I think is really interesting is that these are very different. The first one really only allows access to Azure Managed Services. Well, the second one creates access from any IP that comes out from Azure, which is basically public access. So if you're familiar with the first one, you might see the second one and think, oh, well, I know what that does. But really, it's important to verify with the documentation that you kind of know what's going on and exactly what's going on inside of your inside of the rules that you create. So moving on, the next example we're gonna talk about is more related to Azure SQL Server. And I'm going to talk a little bit about Azure SQL Server firewall rules. So Azure SQL Server is has firewall rules that allow kind of like what I was talking about before. This is the implementation of resource firewall rules within that resource. So it's an IP-based access control list, like we talked about. It only creates a whitelist. But the implementation here is a little bit is interesting. So we have server level and database level firewall rules. What does that mean? So server level rules are shown in the portal, right? You can also view them through the API. You can list them through the API or manipulate them through the portal or API. And these server level firewall rules affect access to all of the databases. So you have in this graph, we have 4 databases, and a server level firewall rule gives access to all of these databases. Database level rules, on the other hand, give access, more granular access, right? It gives us access to either database 1 or database 2. These rules are not shown in the portal and cannot be viewed or manipulated through the API. Again, they're more granular and also more preferred by Microsoft, right? They recommend using database level firewall rules. So when would I use server level firewall rules? If I have a bunch of databases that I need to kind of give the exact same access, the exact same IP address access. If I have a use case like that, it might make sense to use server level firewall rules. But usually that's not the case. And you would want a more granular control over what IPs can access what database. So what we found is a way to create hidden firewall rules within the server. And I'm going to kind of talk about how we did that and what we can learn from it. So in order to create firewall rules for Azure SQL, there are 2 options. You can either do it, like I said, from the portal or API, or you can do it, you can create these rules through functions within the SQL server itself. So we have spset firewall rule, which changes the sysfirewall rules database and kind of sets the rules, the server level firewall rules that we were talking about. We can also use spset database firewall rules, which modifies the sys database firewall rules DB for each database. And that sets the database firewall rules that we were talking about. Now, something interesting happens when you use spset database firewall rules on the master database. So if you create those rules on the master database, it gives access to all the databases. So it acts like, even though it's a database level firewall rule, it acts like a server level firewall rule in the way that it gives access. These rules don't show up in the portal. They don't show up in the API, just like database level firewall rules, but they do give the wide access. So again, another example of, things aren't acting exactly the way I would expect them. I don't have the amount of control that I have in an on-prem network, and really just you might think to set those database firewall rules for the master database, and you'd be giving different access than what you expected to or what you wanted to give in the first place. So I found that really interesting, and one way to kind of avoid falling into this pitfall is to really be um, very aware of the documentation and what the different firewall rules do, and sometimes it's also required to kind of verify um, that what I wanted to do is exactly what happened. So kind of check after you've set the database firewall rule that it's actually doing what you expect it to do and not something else. So let's talk about an attack scenario. Like, how would it look to an attacker coming into an environment that has one of these misconfigurations? And so to create the environment, I created, you can see here, this is a storage account called All My Sensitive Data, right? We got all our data in it, and we wouldn't want that to get out. So um, we've got that there. You can see that I've enabled NFS. You can also see that it's grayed out, right? I can't click that because NFS, once you've enabled it, when you create the storage account, you can't disable it. That was also something interesting that I came across. So I've created that, and you can also see that I've created a private endpoint for that. So here you can see the connection name, you can see the private endpoint name that I've created to connect this storage account into one of my internal networks because it's my sensitive data. I don't want it to have a public endpoint. I kind of want it to stay within the scopes that I want it to stay in. So in this next slide, we can see that I created, right, this is the private endpoint that's connected to our storage account. I've got the private IP here. And it's connected to StorageNet. Now you can also see I have an NSG. This NSG is enforced on StorageNet, and I created a rule here, deny any, for port 111, which is the port that NFS uses. And in a normal network, you'd probably have some allow rules above this rule, right? So that specific endpoints, specific resources would actually have access. Here, I decided to deny access to any just to prove the point. So you can see it's the same IP. This is the IP that the private endpoint has. Now, this is what it would look like on a public VM. Say I have a public VM in a different subnet, right? You can see here it's in a different subnet. It's not in that same subnet that the private endpoint was in. And it might be some kind of public-facing VM that has some workload running on it. And a bad actor could gain access to this VM through a variety of methods, whether it be phishing, credential stealing, exploitation. And say he did, right? First thing you do really when you get to new places is kind of do a little bit of recon. So you ran an Nmap scan just on that 111 port. Obviously, if it was an attacker, it would be a little bit more wide. But you can see here that even though I had those firewall rules or NSG rules enabled, I can still see that it's open, right? 111 is open for the private endpoint. And like we spoke about before, seeing as NFS is enabled, even though when I created that storage account, I enabled ACLs and role-based access to kind of limit the permissions to access the data. You can see here that once I've mounted my storage account, I have access to whatever data was in it. And it's interesting to notice that there aren't even local permissions, right? In an on-prem network, you might have had a domain connected, you had ACLs sort of dictating who could access what data within a storage account. Here, with NFS enabled, there is no such control. So just from that public VM, you'd be able to see Visa1 TXT, right? Might have some interesting information on it. So this is all good and nice in theory, but I wanted to kind of talk about a case that came up that has to do with similar misconfigurations. So it's not just a theory, and it's not just in small organizations, right? It's not just in places that are just starting or just deploying their networks, but it is interesting to notice. So in December 2019, Microsoft exposed the data of 250 million users. Now, I brought this case, but it could have been any organization, really. How did this happen? So a change made to the database's network security group on December 5th, 2019 contained misconfigured security rules that enabled exposure of the data. So you can see here that this is from Microsoft's blog on the event itself. And even Microsoft, who have really good knowledge, I imagine, of Azure, can occasionally make mistakes that in the network architecture that cause access that they didn't expect or didn't specifically want. Now, it's important to note that most of the data that was leaked had PAII redacted, which is another layer of protection that they had in place that was really good. The takeaways from the event that I think are interesting are the decision later to audit the established network security rules for internal resources. So they kind of went and said, okay, internal resources need to have their network controls audited, and also expand the scope of mechanisms. So adding more mechanisms to detect security rule misconfigurations. So again, doesn't just happen in theory, and it can lead to really devastating effects. If you want to learn more about what exactly happened and read a little bit more about this event, you can search for access misconfiguration for customer support database. I'm sure it'll be interesting. So we're almost done. I'm just gonna kind of we're gonna start with the summary and conclusions, and I'm gonna kind of point out what it is that I think or what we recommend that be done in an organization that wants to move to cloud networking. So documentation, right? That's where it all starts. Most of the problems I listed here are stated in the documentation. Nothing, or I shouldn't say nothing, but most of them you can prevent if you just read the documentation, read it again. Make sure that the practitioners, the people who are actually deploying the networks, are familiar with the documentation, right? You should verify the documentation in certain cases, right? If you're relying on a certain control for most of your security, you should really verify that control, and that's what I do kind of for a living. So I definitely believe in it. The next thing we should talk about is adapt your workload to the cloud, right? Don't let the cloud manage you. You should kind of leverage the transition to update your workload. Don't let your workload manage you, what I meant to say. Like I said, backwards compatibility may be useful, but it's also dangerous. So if you're moving and updating, you should use the recommended or the features that are going to be updated, not the backwards compatibility ones that may be deprecated in the future. One of the more important things to do is ensure you're monitoring configurations along with access. So we do have access monitoring, right? That's kind of basic, right? You want to know who's accessing your data, what data they're accessing. You're going to be accessing. You're going to be monitoring those access logs. But it's also really important to monitor the configurations that go along with that access, right? Kind of figure out what exposure is created, like who can access my data, and has that changed, and is that a change that I wanted? So really monitoring that in the cloud is also fairly fairly easy, and I think something that's done easier and is more accessible than in an on-prem network. And from here we kind of get to like what are the three circles that we need to protect, right? Or what are the three circles that we can create to protect? So first of all, data and labeling, right? The data is what we want to protect at the end of the day. I kind of want to know where that data is. I definitely want to know um, that it's within my organization. Configuration and exposure. So, right, how is that data exposed? What are the configurations around that data? What exactly is going on? It's not just enough to know where it is. I also need to know how it can be accessed. And the third most inner layer is finally like, is somebody accessing my data and who I don't want to be accessing my data? Did data access occur? So those are kind of like the three circles that we see. Um, so I think that kind of sums it up. And I want to say thank you. Um, I enjoyed talking, and I want to say thank you to Drago also for organizing this event. You can reach out to me, my email. I also have for many of the use cases or many of the misconfigurations that I presented. I have some PowerShell and resource graph scripts that you can run to kind of see if um, they exist in your organization, and I'm happy to share them with you. So just reach out and try to help. So thank you very much, and thank you for coming.